for the next one is a goal of modal analysis. Let us see the goal of modal analysis. And first one is the goal of modal analysis in structural mechanics is to determine the natural mode shapes and the frequencies of an object or structure during the free vibration. So whenever you talk about the free vibration, so if the excitation happened without any external aid of force, that is called free vibration. So whenever this vibration occurred, so in this one we can able to see that natural mode shapes as well as frequencies of an object. So the modal analysis particularly used to determine the natural mode shapes and the frequencies. Okay, so these things we are going to be seeing in this free vibration whenever the free vibration is there. Then the next goal of the modal analysis is, it is common to use the finite element method to perform this analysis, because like other calculation using finite element methods, the object being analyzed can have arbitrary shape and the results of the calculations are acceptable. So if the shapes and everything is irrelevant, if the shapes as well as the shapes of the object is arbitrarily, and it may be that not constructed way, therefore the calculations are going to be accepted in this modal analysis. And next one is the type of equations which arise from modal analysis are those seen in the eigensystems. So here in this one, we are going to be see that how to find the eigenvalues and eigenvectors. So already it is taught in the mathematics, but anyhow we're going to be recalling that how to calculate the eigenvalues and eigenvectors. Here we are going to be frame the governing equation for each and every problem. So before formulating the governing equation, these are called as some of the basic points. So that's why my intention is we should know the some of the basic points before attempting any dynamic analysis problem. So in the next session, we may be going to be define what is the governing equation for dynamic analysis problem. So once we define the governing equation for the dynamic analysis problems, that dynamic analysis governing equation is applicable for all dynamic analysis problem. So means that one governing equation can be used to apply all type of dynamic analysis. So we're going to be derive that the governing equation in the next successive classes. So once you use the governing equation, by using the governing equation, we can able to find out what is the natural frequency, what is the mode shapes, what is the force frequency, and all other depending upon what are the boundary conditions that are given in the dynamic analysis. So there are the different boundary conditions given in the dynamic analysis that may be belongs to the free vibration boundary condition and forced vibration boundary condition. There are the two types of boundary condition. One is called as a free vibration, and second one is a forced vibration. Whenever the free vibration is there, there is no external force acting on a member, but it is going to be excited. If the force is acting on a member, because of the force, the member is going to be excited. This is the only two difference between the forced vibration and free vibration. In these two cases, we are going to do the modal analysis in the unit number 5. So in this one, first we are going to be formulate the governing equation. To formulate the governing equation, we should know the sum of the basics. So to cover those basics, we cover all this entire first lecture. So this first lectures will give the introduction to the some of the useful words that belongs to the dynamic analysis. That is my intention. So that's why we taken the necessary terms that are belongs to before deriving the dynamic analysis equation. So there are the two types of vibration. One is a free vibration, forced vibration. In the free vibration, there is a governing equation is there, and forced vibration, there is a governing equation is there. That governing equation we can elaborately discuss in the next successive classes, and it can be derived. I'm going to one more clue. It can be derived by using the Newton's second law. So F is equal to ma. So using that F is equal to ma, we are going to be define the dynamic analysis governing equation for all type of dynamic analysis problem. So that can be elaborately discussed in the separate session. So before going to do that one, and we're going to be see some of the basics. That is my intention. That's why we gather all this information and we'll put down in front of you. So no problem. And next one is the physical interpretation of the eigenvalues and eigenvectors which come from the solving the system, and systems are that they represent the frequencies and the corresponding mode shapes. We're going to be see that what is the frequency and what is the formula for the frequency, and what is the natural frequency, what is the forced frequency. So these things will be going to see in the successive class. And what is the eigenvalues and what is the eigenvectors, these also we're going to see elaborately in the successive classes. And how to find out the eigenvalues and eigenvectors for a dynamic equation problem, that also going to be seen. So in this dynamic analysis, we're going to be see that the three important things, one is called as a how to derive the governing equation, then how to find out the eigenvalues and eigenvectors. So if you found these three terms, the rest of the dynamic analysis problem is very easy. So let will focus on the next one. And sometimes the only desired modes are the lowest frequencies, and because they can be the most prominent modes at which the object will vibrate, dominating all the higher frequency modes. So this is also going to be one of the goals for the model analysis. So these are the some of the goals for the model analysis. And let will stop